I'm Kosan Professor, Primary 6 from YUMIN Primary School. We'll go on with our summary for our methods of limit calculations. So, in this time our summary, let's go on. Let me tell you, I want to tell all of you, I want to emphasize on, in the future, when you meet these types of series, know these methods and you'll be able to solve them easily. So we want to make a summary to show for all these methods. So for this, well, what we have done before was a 1/3 plus 1/8 plus 1/15 plus 1/24 and so on. But for that, it was only a 2-term. But let me tell you more about this. So for that, at first, it is S equals. So this is just for example. For example, because this sigma, you can write it in many forms. But we just stick to one of them first. So what if it is like this? Then we let a function 2 equals. Okay, we want to remove our denominator. But this x, the power, we have many powers. These powers include n or n plus 1. N minus 1. All these plus how many minus how many, they all can. All of these, you can use them. But what if, because that these right now that I wrote down is only if n's coefficient is 1. How about other coefficients? So others, for example, 2n, 3n, or fractions. Fractions, well, you also can use it, but these will change how simple this working would be. So all these powers, you can use it. There are infinity powers that you can use, but it depends which of them are the simplest. Okay, this is just 2 of these at the denominator. But let me just tell you one important thing. All this power, they must be linear. Now, I have shown you before, if it is not linear, if you have square, I've showed you that, and you have no common ratio. So this must be linear. Now those squares, cubes, you cannot have them. So this linear, you will think of something that we have learned before, mx plus c. So basically, this power, just in any form of this, will do. Okay, so how about the 3? So we also could let it be an s, because this stands for the sum. We add them up all together. For example, if this is our original question, let's first think what types of methods we can use so that when you meet any type of these questions, you will know which methods you can use. So let's think of what kind of methods have we used before to solve that question. So methods. Firstly, we got partial fractions. Well, you can partial fractions, you can also don't partial fractions. So what if we partial fractions? So at this part, Well, 1 over n times n plus 2 times n plus 4. So you can first split it into 2 of them and 2 of them first. Now this is the method partial fractions. But in front here you need 1 over 4. So it's like this. Then after that, if this question has to, you can still continue to split. Or also can be called partial fractions. But these partial fractions, there are different methods, whether you want it in this form or you want it in this form. It doesn't matter. But it's just the method you're using is different. So after that, you can just split and combine them yourselves, or I can show you some. So half is a common, so take them out. Okay, so this is the method of partial fractions. Then after that, you can go on and solve whatever you want. This is the method of partial fractions. Well, what other types of methods do you have? So, other types of methods, you can straight away use it in this form, and then it will become using differentiation and integration. So what happens there? Now in this form, you have to think of the power. You have to think wisely which power you should use. Well, best is to use the biggest. Okay, so that later on it will just be x to the power of something. But for all of these, you must be careful of their differentiation and their integration. So what happens here is that this n to the n plus 4 would become its power first. They'll just keep on solving. Okay, but what's so special? What's so special in between this differentiation and integration? But this sigma, you have to be careful. This sigma, you add all these up. But in the middle, when you add all these up, you'll realize there'll become some kind of pattern there. So that is what we call it, the GP, geometric progression. But right now what we are using is with infinite terms. So I have to add them up with infinite terms. So you could just write as infinity. Now what would this be? So we have always let it be a1 over 1 minus their ratio. A1 as the first term. Or if you don't write A1, you can write it as small t1 or capital T1. There are different ways, but they're all the same thing. So this is about that geometric progression. Now what other things? Now, let me just tell you, this thing is actually an application of our limit calculations. So this is an application of these. But this, you have infinite terms. So you apply for infinite terms, and at the same time, when you change it, it becomes a power series. Then what happens? Although you put inside this limit, you have to be careful. At last, you must be sure that it becomes convergent. That is, you have a fixed answer. But if it becomes divergent, it can become infinity, and nope. So in the future, we'll show you how to show whether it's a convergent or is it divergent. But for all of these, methods are actually the same. When you meet one type of question, you don't have to worry. Now, let me tell you why. These methods are actually just like that. You can use partial fractions or you don't use. Now you have, you have 3 of these things times together in the denominator. So what you can have is, you change it into 3 times differentiation and then 3 times integration at the same time. For example, like this. So after that, you'll differentiate and then integrate. After you want to remove all of these denominators. So and then this is just once. Because you have 3 of these things times together in the denominator, so you'll get 3 times differentiation and then 3 times integration. Then in the very middle, you'll use the geometric progression. And after that, you can use whatever methods you want. But you have to be aware whether this power and this denominator is corresponding, because you must make sure that they're corresponding first before you can differentiate and then integrate. So in this case, because it is not corresponding, you have to be, is it you need to take away or you need to add on? So in this case, the power is bigger than this denominator, so you have to take away. So you have an extra x. After that, inside here, now you're sure that it becomes n plus 2. Now this is just an example. Okay, then after that, you actually use the same method again. Now, using these different methods, but at last, wait, I missed out one thing. Okay, there. So you'll get this like this. Then after that, what's left, you just check again, and then you try to make that match. Then after that, using whatever methods you have, and trying them out. So x to the power of n becomes x to the power of n. Then after that, here you have 3 times, then in the middle, you can already start to solve it. Okay, but which example you are having, their methods are actually all similar. So it's just whether you want to use partial fractions or you want to use this integration and differentiation. So all these, you look at the denominator. When there's how many of these times together, will tell you how many times you have to integrate. But let me just tell you one thing. This part when you change it into like this, let me tell you, there's actually one special method. Sometimes you just use like this and then x to the power of something for all of them. But one very good method, you split it into 3 of these sigmas. So that is, okay, now I don't need to write them because you can already see them clearly from here. So for this, that means from here, make the power and denominator corresponding. Here, power and denominator corresponding, same thing. So then after that, for that method, so this is 4. So this power and denominator. Now this 2, because when the 2 is there, it is very annoying. So a good method is to take that out. So to make it so it becomes like this. That for each of them, you differentiate and integrate. Then you use those methods that you have known. So like this. But no matter how many of these are in the denominator, the methods are pretty much the same. It's just whether here you have to use 3 times geometric progression. Here you just once. Okay, and for these, it might look like triple integration, but the truth is iterated integration, just that it is doing it 3 times. Okay, you have to be careful whether triple. Nope, this is not triple, this is just iterated. If you have triple, then it's definitely going to have 3 variables. So that's another thing. So for this part, you have many different methods. Now, if you have 4 of these below, you have 4 of this thing. And then at this denominator, you have 4. So you have 4 times of this integration. Other than these 3 methods that I have said, there is one other method. So instead of using the method of after you partial fraction that you simplify, what if you don't want to simplify them, like as in cancel them? So we could construct a function, or you let. So you can also make. So what would this be? So this front part, we let it stay the same. But at this back, x to the power, it depends on you, whether you want n plus 1, n plus 2, n plus 3, or n plus 4. Well, you can use any of those, but let me just write out what kinds of methods would I recommend you to use when, for example, you're in an Olympiad or you're in a test. So let me recommend you these methods. The first method, so you can straight away partial fractions. That would be the fastest. But if you cannot straight away partial fractions, well, at least try to change it into a form like this. So this form did you realize this is just extra part of one thing? So what we call it is, it's just one series or one power series. Then what else? Okay, this method. Now what kind of method do we call this? So you'll realize here we have 3 power series. So what we have done before, we have 2 of them. So we can just call it 2 or more power series. Then what other method that we have used? Okay, this part. What kind of method do we use for this? This type of integration, what do we call it? The iterated integration. But there are actually many other methods that you can use. But these 4 methods, I would recommend you to use them. Okay, so these are what I actually wanted to mainly talk about, or we study mainly about these. So these 4 methods are those types of methods that I will recommend you. But inside each method, there are many other ways that you could use them in one way or another. For example, this power, it's up to you whether you choose. Well, it depends what you choose. So for these types, there are many types. And don't be scared when there are many of these times in the denominator. Well, because there is no standard method for this. There is no fixed method. If your method is reasonable, you can use it. But during the process, you might want to try to simplify a little bit so that mistakes will not be easily made. Okay, so for this part, I think you can understand this. So if you like our videos, don't forget to subscribe to our channel. So we'll see you in the next lesson, and thank you for your watching.